There we go. So we had just started talking about, just calculating simple interest, and we had looked at a few different types of examples, and just, how to calculate your interest, the dollar amount. We had also talked about how to calculate your future value. And actually, one of the last examples we had seen was about calculating the present value. If you knew what your future value was going to be, how much your present value should be. So how much you should invest now, so this was kind of the example that we had looked at. So the next thing we want to get into is, as you can see here, we're talking about the add-on interest. So when we're talking about the add-on interest rate, interest loan, as you can see, we're saying this is an older type of loan, and this was, before calculators and computers came about. So these calculations, were basically, those could be done, by hand. So saying, these have been basically been replaced, with obviously with the modern technology, with more, they're talking about borrower-friendly amortized loans. Now, we'll not be getting into section 5.4, but if you just kind of wanted to look through those, you can go to your e-textbook through WebAssign and take a look at those. So they're saying, basically with this type of loan, we're saying the interest for the entire term of the loan is calculated as if no payments were being made, until the loan is maturing. So that's happening as though, you were going to end up making all your payments at the end of the loan, when the maturation time happens. So they're saying the total interest in this case is added onto the principal, and the borrower will basically repay this total amount, with equal payments over the term of the loan. So just as our terminology here again, to find our monthly payments for these add-on interest loans, your P value, the present value is now actually going to be the loan amount, so how much money has been borrowed. We will be using the simple interest formula to calculate our interest I. And then remember, this is again going to be on the loan amount, and we're obviously making the assumption that none of the payments have been made till the end of the loan. And then we're talking about finding the amount that has to be repaid, which will be, adding your principal or the loan amount with the amount of interest you have, and then you of course divide by the total number of payments that we will be making. So as an example here, we're talking about Chip. Douglas's car died and he must replace it right away. Centerville Auto Sales has a 9-year-old Ford that looks like new at $5,988. The sign in their window says, Brad credit, no problem. They are offering Chip a 5% 2-year add-on interest loan if he made $600 down payment. So they want to know what his monthly payments are going to be. So the value of the car, at which they're selling is $5,988. Now you can see they're talking about $600 worth of down payment, right? So that's the amount you pay right at the time that you will purchase the vehicle, or I guess Chip pays when he purchases the vehicle. So that's why we're taking that total dollar amount of $5,988, subtracting the $600 for it, which means the loan amount he's going to borrow is just going to be in $5,388. Now they're talking about a 5% add-on interest loan. So, using your simple interest formula, you can see again, that's I equals PRT. So that's your principal, the amount of loan, that's the rate of interest at 5%. And, they are telling us this is also a 2-year add-on interest loan. So that's our time frame. So when we multiply all of this together, we end up getting an interest dollar amount of $538.80. So that will be added with the $5,388. And this tells us this is how much the total amount, Chip will have to pay back. And since we are talking about, monthly payments, and this is a 2-year loan, then of course that means he will end up making 24 payments over those 2-year periods. So then we take our total amount over here, $5,926.80, divide by 24 months, and you end up getting a monthly payment, as you can see, of $246.95. So, that's going to end up becoming his monthly installment in a way, that he's going to end up paying. So you can see, as far as the calculation goes, it's very similar to what we were looking at last time, but this one is just in terms of that payment amount will stay the same, as he's making these payments over this 2-year period. So let's see if we can do just an example here from our textbook. Let's see, we had done these examples last time, so let's take a look. Not finding an example that I did. Okay, so these ones are actually not giving me an example for the add-on interest. All right, let's look at this one. I kind of like that one already. Let's take a look at number. So yeah, very similar to the example we're looking at. So let's look at number 32 over here. So this one is talking about okay, so this one is saying Sven Lundgren buys a 3-year-old Chevrolet from Skunk Motors for $14,600. He is putting down a down payment of $300, and they're saying he finances the rest through the dealer at a 12.5% add-on interest loan. If he agrees to make 24 monthly payments, what the size of each payment is going to be. So as you can see, the example is very, very similar to, the one we looked from our handout. So let's go ahead and see what these monthly payments come out to be. Okay, so let's put this information down over here. Okay, so our principal amount that, the loan will be borrowed for so the value of the car, at which he bought was $14,600, but then they're saying he puts down $300 for, down payment. So that means, like you saw in the example, we will need to subtract 300 from this amount. Then as far as our rate of interest goes, you're talking about a 12.5% add-on interest loan. And you can see they're talking about making 24 monthly payments. So again, we know 24 months is of course the same as 2 years. So that's going to be your time frame. So using that information, we can actually calculate what our interest is going to be. So, first of all, let's go ahead and finish the subtraction for the principal. So, of course, if you take 14,600 and subtract 300 from it, you're basically just taking that 600 part and subtracting 300 from it. So you will end up with 14,300 as your principal amount. Remember, for percentage, we always convert percents to decimals. So what do you think that rate, 12.5% as a decimal, is going to be? So when you convert 12.5% to a decimal, what will we have? Very nice. Yeah, you will have 0.125%. Alrighty, so how much interest will Sven need to pay on this loan? To use that simple interest formula, and what kind of interest dollar amount do you end up with? So what do you end up getting for this? Okay, let's see, so 3,575. Let's see, Molly and Maribel, you guys got the same answer. Okay. And then remember, you will need to add that back into the borrowed amount, which was the 14,300. So let's see, that's going to be, and it looks like the battery on my pen is starting to go down a little because it's been acting finicky for the last 2 days. Okay, so let's see, you guys got 17,875, Ethan, Molly, Maribel already. Very nice. So this is the total amount, Sven has to pay back to the dealership. So this is the dollar amount you are going to be dividing by, your 24 payments, monthly payments. And so what does he end up paying for each month? So what are you getting as your monthly amount? $744.80. So you've got 79 cents, Logan. All right, so let's take a look. We have 744.79166. Repeating. So yeah, since you have 79 and there's a 1 after that, you can actually just round it to 744.79 cents. Alrighty, so this will become our monthly payment for Sven with his, Chevy, whatever he ended up buying over here. Yeah, a 3-year-old Chevrolet from Skunk Motors. Now, of course, you can see he does have a higher dollar amount, 14,600. He's only making a $300 down payment, and that interest rate is pretty high at 12.5%. Now, the example we were looking at in our handout over here, this person was only borrowing about $5,400 at a 5% interest rate. So you can see at that how small these monthly payments were. But then in our example, of course, everything is a lot higher. So you end up having a higher monthly payment. Okay, so that was just to kind of show you how these add-on interest loans work out to be. Again, you can kind of see with credit card charges also, it works a lot differently than, what we're seeing over here. So with credit cards, they actually talk about calculating your credit card interest based on the average daily balance. So when we're talking about the average daily balance, we are saying it is the weighted average of the daily of each daily balance, with each balance weighted to reflect the number of days. So basically what happens is they will see how long the balance that is on your credit card has stayed the same for that day. So, because obviously with credit cards, if that's one of the main sources you use, instead of, using your bank card, then, that daily balance can change every day, because if you're making new purchases, every other day or something like that, depending on what's going on, then that daily balance is going to change. And let's say somewhere in the middle of the month, you were like, okay, I'm going to go ahead and pay some amount towards my credit card balance, then, that balance will drop and you will have a new balance. So that's why with credit cards, you have to look at what that average daily balance is going to be. So like they said, this is a weighted average for each daily balance. So to find the credit card finance charge with the average daily balance method, they're saying, start by finding the balance for each day in the billing period and the number of days that balance, stayed the same. So the number of days at that balance. They're saying the average daily balance is going to be the weighted average of these daily balances, basically weighted to reflect the number of days. Again, how long did it stay at that balance? The finance charge is a simple interest applied to this daily average. So let's take a look at this example here. We're talking about the activity on Tom and Betty's Visa account. For one billing period is shown over here, and this is actually going from a billing period of October 15th to November 14th. They're saying the previous balance was $346.57, and the annual interest rate on this credit card is 21%. So you can see this is a billing period from October 15th to November 14th. They're saying on October 21st, there was a payment of $50. On October 23rd, there's a restaurant, bill of $42.14. November 7th, there was a clothing charge of $18.55. So the first thing we have to do is, calculate what this average daily balance is, and then we'll look at the finance charge for this. So they're talking about, looking at the days. So if we go from, and let's try and keep this dates here visible for us. So we are going from October 15th through October 20th, because, the first charge that happened in this billing period was on October 21st. You're looking at what the balance was before that. So from 15th through 20th, that's going to be a total of 6 days. And, they're telling us that our previous balance was $346.57. So during this billing period, the previous balance was at $346.57. So that's for 6 periods. On 21st, when this payment of $50 happened, that means, you paid $50 to the credit card. So from the 21st to 22nd, that's 2 days, our balance dropped down from $346.57 to $296.57, because that's, subtracting those $50 of payment. Now on October 23rd, we made a purchase. So from 23rd till November 6th, because that's the day before this November 7th charge happened. So from October 26th to November 6th, you can see that's for a total of 15 days, because that's 9 days in October, 6 days in November. So that's a total of 15 days. You had the $296.57, balance from October 22nd. Then we made a charge of $42.14. So now our new balance goes up to $338.71. And, after November 6th, on November 7th, we made another purchase of $18.55 for clothing. So that goes from November 7th till the end of our billing cycle. And again, if you see, our billing cycle ends on November 14th. So November 7th through November 14th, that's for a total of 8 days. Our balance stayed at, 357.26. So you have to literally look through what the charges were, how long did your balance stay at that charge, and then you have to calculate your finance charges. So once we have this, table completed over here, now we do our weighted average. And if you remember, we had talked about weighted means in, beginning of chapter 4. So what you have to do now is take the daily balance dollar amount and multiply it with the number of days. So we would take our $346.57. It stayed at this balance for 6 days, so we multiplied by 6, and you will see that's our first calculation here in the average daily balance bottom of your screen. Then the balance of $296.57 stayed at 2 days. So you're going to be multiplying 2 days with 296.57. The 338.71 was for a total of 15 days. So we are multiplying 15 days with 338.71. And then the final balance of 357.26 stayed in our account for 8 days. So you're multiplying that into 8 days. And then to get your denominator, you're actually adding how many total days that we have in this month. And, that's of course going to come out to be, 31 days. So you're basically dividing your numerator by the total number of days in this billing period, which comes out to be 31 days. And so now this is how you come up with your average daily balance. So we're saying on an average during the month of October 15th to November 14th, on an average, our daily balance stayed at, about $342.30. Oops. Okay. Just a minute here. All right, guys. So now let's talk about finding those finance charges. So now we have our daily average daily balance, and they're actually using the non-rounded number over here, which is the 342.29967. So that's the number they're using over here. Okay. They are telling us that the annual rate of interest on this credit card is 21%. So that's where this 21% or 0.21 is coming from. And since our billing cycle had 31 days in it, to convert it into years, you take that 31 and divide it by 365. All right, thank you, Cooper. And so, again, remember, anytime you're calculating these, using these interest formulas, your time has to be changed into years. So 31 days divided by 365 days, and that converts it into year. So just plug those numbers into your formula. So you can see here is our average daily balance, our rate of interest, and our time. Multiply those all together, and that shows us that we are going to end up paying a finance charge of $6.11. And, again, this is a rounded answer from over here. And so that's how they will be calculating, what your finance charges are going to be for this month of October 15th to November 14th. So it kind of, if you remember, this kind of looks like what we had talked about with these examples over here, which were based on the small short-term loans over here. That was kind of the same thing, because we had to calculate, how many days the loan was taken out for and how, we were going to do. But, obviously the calculation is a little bit different, because this is, your balance is changing from day to day. And so that means you are actually looking at for how long did the balance stay the same in your, credit card account. And that's how we are having to calculate this weighted mean. And then once you have that weighted mean, that becomes your, sort of like your loan amount for that month. and then you multiply it by your rate of interest and for how long, you know, that billing cycle was. All right, so let's take a look at this one over here. Now we're talking about financial calculations usually involve computing, you know, the term T, which is either going to be, you know, the number of years as whole numbers, or they can be number of days, which are being converted into years. So they're saying this requires that you know what number of days are going to be in each month. So they're basically showing you, you know, how many days are in each of these given months. Now, actually, I don't know if they have that illustration here or not, but maybe it was in a different textbook. But basically, you can see they're listing all the months that have 31 days, and you can see that's going to be January, March, May, July, August, you know, October, and December. These are all 31 days. The remaining ones are 30 days each, with the exception of February, because, you know, February is 28 days, or during a leap year, it's going to be 29 days, depending on, you know, every 4-year cycle. The rest of them are going to be 30 days. Now, you know, when I was growing up, and let me see if I can show you guys this illustration, we used to actually use our knuckles to do the calculation. So, you know, the knuckle part is where you have the 31 days, and the little dip that you have between the knuckles are your 30 days, or, you know, for February, that becomes your 28 days. So you always start with, you know, January on, you know, the beginning. If you go January, February, March, you're going to fall back on your knuckle. April, May, June, July. And July and August are the only 2 consecutive months in a year that go 31 to 31 days. Every other alternate month, you know, you are looking at 30 days. Now, if you talk about consecutive again, then, you know, you go from December to January. So those are, again, consecutive months that have 31 days each. But, you know, technically we think of December ending the year and January beginning a new year. So if that's something you guys have used before, you definitely can. But that's how I honestly would remember how many days were going to be in a month. And, you know, of course, if not, you always have this chart to help you out. So you will see July and August are the only 2 months, you know, beginning from January to December, that are consecutive months that go from 31 days to 31 days. So let's take a look at, you know, calculation over here. Now, this is a really neat example here, kind of talking about, you know, student debt, which is definitely a big crisis in our country right now, because, you know, so many students are, you know, they took out these high interest loans, and even after being several years into their jobs, you know, they still have not been able to pay off these loans. And, you know, especially if you have a huge dollar amount, like for medical students and stuff like that, when it's in 6 figures, you know, it can take almost a lifetime to pay up those loans, you know, to finish paying them. So it's a really neat example. You can kind of, you know, read through that and get some idea. But let's pick an example here for this credit card example that we just talked about. All right, so let's take a look at this one here. So number 38. So this is talking about the activity on Marnie Zell's MasterCard account for one billing period is shown below. Find the average daily balance, find the finance charge if the billing period is from June 26th through July 25th. The previous balance on the card was $396.68. The annual interest rate on this card is 19.5%. So again, you can see the different payments. June 30th at $100. July 2nd was gasoline at $36.19. And July 10th, we have a restaurant bill with $53. So let's take a look at, how to break down these average daily balance and finance charges. There we go. Okay, so let's put down the information we have on hand. So our billing cycle is going from June 26th to July 25th. Our annual interest rate is 19.5%. And let's see what else they're telling us. The previous balance is $396.68. Now let's look at the other charges that we have. So we've got June 30th. Oh, come on, buddy. June 30th is a payment of $100. July 2nd is gasoline at $36.19, and then the last one is July 10th for a restaurant at $53. Okay, and I believe that's all the information we have here. Okay, so let's create a table. You're going from June 26th, so that's our beginning. So if we are going from June 26th, and the payment happened on June 30th, which means you are looking at June 29th as the the day before. So if you're talking about going from June 26th to June 9th, how many total days is that? To June 26th to June 29th, how many days do you think that is going to be? It is going to be 4 days, because if you just did a subtraction, you would get 3 days. But remember, you have to count June 26th, 27th, 28th, and 29th. So that adds up to 4 days. So we are looking at 4 days where the balance was at, our previous balance of $396.68. And then from June 30th is when we made this payment of $100. So, this is where you're taking this previous balance of $396.68, and you're going to be subtracting the payment of $100 from that. Oh, come on. There we go. So, of course, this will go down to a balance of, let's see, $296.68. Now, your next payment, or whatever activity on your card happens on July 2nd, which means here you would be going to July 1st. So June 30th is when we made the payment of $100, and July 2nd is when we bought gas. So what do you think that time period is from June 30th to July 1st? And again, you got to think about how many days does June have? Is it 31 days? Is it 30 days? So going from July 30th to June 30th to July 1st, how many days are you looking at? Yeah, it's going to be 2 days, because remember, July only has 30 days. So, oh my God, June only has, 30 days. So June 30th, of course, would be the last day, and then July 1st would be, the new day. So that would be a total of 2 days at this balance of, $296. You know what? I think I'm actually going to write this over here. $296.68. Out of the way. And then our very last charge happens on July 10th. So that means starting on July 2nd is where we, purchase gas. And since July 10th is the next date, that means this guy is going to July 9th, again, the day before. And this time we had a balance of, $296.68 from here. And then since we made a purchase of gas, we would be adding these $36.19 to it. So you would get a new balance over here. So what is our new balance? And again, from July 2nd to July 9th, how many days are you looking at? All right, Markley, you're talking about 8 days. Okay, Ethan, you've got the same number. Logan, very nice. Molly. And then what's your new balance now at the end of this July 9th date? All right, Markley, let's see, you've got $332.87. All righty, very nice. Good job, guys. So let's see, that's going from July 2nd to July 9th. We had a balance of $332.87. And then the very last one, we are now going from July 10th to, let's go back and see, our billing cycle is ending on July 25th. And, of course, you will see after July 10th, we have no new activity on our card. So from July 10th to July 25th, we're going to have this final balance. And so that is going to be our $332.87. And this was, your restaurant bill of $53. So we will be adding $53 to this new total. So same thing, what's our number of days and what's our new balance over here? $16 days, okay. Logan, 16, all righty. And what's your dollar amount? All right, let's see, $385.87. Markley, Isabel, Maribel, alrighty. $385.87. And you guys said 16 days. So let's see, 25 minus 10 is 15, and then plus 1 would be 16 days. Alrighty, very nice. So now we actually have what the balance is and for how many days. Now we can actually calculate our average daily balance. So let's do that first. Okay, so before we actually get into that calculation, I wanted to see if any of you had a question on how we did this really badly designed table, how we calculated our days and then the balance for that number of days. Is everybody okay with these calculations as we went from June 26th to July 25th? Anybody have a question on that? Okay, Isabel, you want to know why do we subtract? So are you talking about subtracting that $100 at the beginning? Yeah, okay. So the reason we are subtracting that $100 is because they're specific, and let's go back over here, because they're specifically telling us that this is a payment. So payment means you are actually paying the credit card company, right? So when you had that balance of $396.68, you are making a payment, right? So when you pay the credit card, your balance goes down. And then when you make a purchase, right, your balance will go up. So that's the reason why here, so that's the reason why here, when you're taking your payments, you subtract, but then when you're making a purchase, you're buying gas and you are buying food. So purchase needs to be added, but payments, they need to be subtracted. So that's the reason why we are subtracting the 100, but then we are adding the other two. All right, very good. Did anybody else have a question on the table before we get into our calculation for the average daily balance? Okay. So remember, this is your weighted average over here. So the way we're going to calculate this, you are going to take the dollar amount, and I'm going to highlight these in green. So you're going to take your dollar amount and you're going to multiply it by the number of days our balance stayed at that dollar amount. So you're going to take each one of these dollar amounts and multiply it by the days. And then we're, of course, going to add up everything together. So each one of these dollar amounts have to be multiplied by their days. So let's see, we're starting out with 4 days at $396.68. And if it helps, you can put these in parentheses also, so you're multiplying. Then we add, move on to the second one. So this was 2 days at $296.68. So 2 days at $296.68. Then the next one, we have 8 days at $332.87. And then the last one we had was 16 days at $385.87. So this will give us your numerator. Now, basically, you have to calculate how many total days you have over here. So you can either do it from here, or you can do it from here to figure out the total number of days this billing cycle has. So if you go from June 26th to July 25th, how many total days are you looking at? Okay, let's take a look here. Burgundy, you've got 30. So let's see, 16 plus 4 will add up to 20. 8 plus 2 will add up to 10. So 20 plus 10 will give you 30 days. There we go. So you can do it, just by adding these numbers, or you can just do it from here and you get a total of 30 days. So that means you're actually going to be dividing this by 30. So, take your time and let me see, what do you get for your average daily balance over here? Okay, let's see, Markley, you came up with 367.222, and it looks like Molly, you have the same number. All right, so when you just multiply the numbers on the top and add them together, that total comes out to be, let's see, $11,016.96, and then we divide that number by 30. And let's see, I've got Isabel 267 2187, and Logan, you've got 267 232. So okay. Do you think you entered one of your numbers incorrectly, Isabel? Because you're off just in your decimals, it looks like. The number dollar amount looks good. So yeah, we've got average daily balance of 300. Come on, there we go. 367.232. So that looks good. We should not really have that decimal there. Alrighty. So once you find your average daily balance, then remember that becomes your principal amount. And let me just show you. So once you found your average daily balance, then you know that becomes your principal here. And then you take your rate of interest and you know the number of days, and you multiply those together. So for our example, for our finance charges, our principal amount, and you know, again, remember this kind of acts like the loan amount that you've taken from the credit card company, is going to be 367.232, and you are actually going to keep all your decimals. So don't round your answer over here. Our rate of interest, remember they gave us 19.5% as our annual rate of interest. So that's going to be our 19.5%, which we will convert into decimal again. So, you know, of course, this will come out to be, move that decimal 2 places to the left, and you get 0.195. And then our time, remember time is always in terms of years. So since we ended up getting, you know, 30 days, which is the total we got over here, 30 days, you take that 30 days and divide it by 365 so that we can convert this into years. And then we calculate our interest based on the simple interest formula, ERT. So that's going to be your 367.232 being multiplied with our rate of interest of 0.195, and then being multiplied with our time, which is 30 divided by 365. So what do you think your finance charges are coming out to be for this example? And this one, since we are talking about, you know, the final dollar amount as final finance charge, you will round this to 2 decimal places. So what do you have? Maribel, you had $5.73. I had a little bit of a different answer than that. Marky, you got 589. Did anybody else have another answer than what we're seeing over here? And so as your raw answer, let's see, this is coming out to be 5.885 77, and the number keeps going. Ethan, you got 0.588? Oh, 5.88, okay. Yeah, so since, with dollar amounts, we rounded to the nearest cent. And since we have a 5 after that, that actually makes that 8 go up by 1 unit. So as your rounded answer, you will actually end up with $5.89. So this is going to be, the finance charge, which will be applied for this month of, June to July. So that's basically what you'll end up paying. So questions on the second half of the problem where we calculated our average daily balance and then calculated our finance charges. Did anybody have any questions on that? Alrighty, so that credit card example was the last one we wanted to look at in 5.1. So let's move on to section 5.2 next. And this is actually where we are getting into our compound interest formulas and calculations. So we're talking about how different forms of investments, it can be savings account, are going to end up earning compound interest. Now, compound interest, actually what happens is compound interest is paid on the original principal that you are investing, but it actually also makes, well, I guess it calculates interest not just on the original principal, but also on any previous interest that your investment account would have earned. So they're talking about this is where interest is periodically paid on the original principal amount and any previous interest payments. So what happens in this case is these earnings actually end up being quite a bit higher if you compare this with simple interest earnings. So because you're earning interest on the original principal, but you're also earning interest on any of the older interest payments you would have received. So on those interest payments and the principal, so these dollar amounts end up growing a little bit faster than what a simple interest would do. So they're saying the earnings are going to be significantly higher, especially over a long period of time. So they're talking about, just looking at compound interest as a simple interest, which is being repeated. So let's take a look at this example here. Tom and Betty deposit $1,000 into their new bank account. They're saying the account pays 8% interest compounded quarterly. So that basically means that your interest is going to be calculated at every quarter of the year, which every quarter comes out to be every 3 months in a year. So what happens when they're saying compounded quarterly is they're going to take this 8% interest and they're going to, break it up into 4 parts. And then at each quarter, you're going to get this interest calculated and this interest added to your bank account. So they want to know after 6 months what the account balance is going to be using the simple interest formula, using the simple interest future value formula. So our principal, the amount that we are depositing is $1,000. They're telling us this is a rate of interest of 8%. And we are doing this compounded quarterly, which means we're only doing it for the quarter of a year or, 1/4 of the year. So using this future value simple interest formula over here, we take our principal at 0.08, 1 plus 0.08 times 1/4. 1/4 is your time, 8% is our interest. So you can see when you take that 8% and break it up into 4 equal parts, technically for each quarter, you would be getting a 2% interest rate. And then that's being calculated on that $1,000. And, at the end of that first quarter or 3 months, the balance in your account is going to be $1,020. So this was at the end of the first quarter. So now they are saying, okay, so what will happen at the end of the second quarter? So at the end of the second quarter, your new balance is actually going to be $1,020, right? Which is what we had from this calculation over here. So that actually becomes your principal now. Going into the second quarter, same rate of interest, but we are again only doing this for 1 quarter. So your time is still going to say, 1/4. As you can see, they're talking about it's not going to become 2/4 because we're again only calculating the interest for the next 3 months. And 2/4 would be half a year, which would be 6 months. It's not going to be 2/4. It's still, the time is still going to say 1/4. So same calculation you will see inside the parentheses, 1 plus 0.08 divided by 1/4, which comes out to be 1 plus 0.02. So in our second quarter, we would still be calculating at 2% interest rate, but what's changing between the first quarter and the second quarter? In the first quarter, our balance was $1,000. At the end of that quarter, our balance changed to $1,020. So you will see how we actually now earn an interest of $20.40 because your balance increased from $1,020 to a new balance of $1,040.40. Now, if you had just done this original calculation without the compounding quarterly, so think about this. If we had just done the original calculation where you had $1,000 to deposit, we were depositing this at a rate of 8%, but you were only going to do this for half a year because they're still talking about calculating this for 6 months. So you would multiply this by half a year. So this calculation would come out to be 1,000 parentheses 1 plus 0.04. And when you would have calculated this, you would have actually ended up with 1,040 as your balance at the end of 6 months. So, of course, you are getting a little bit of that extra 40 cents. Now, it may not seem like a significant amount, but think about, if you were depositing 6-figure instead of $1,000, $100,000 or $500,000, something like that. And instead of doing this for 6 months, you were, leaving the money in there for, let's say, 10 years, maybe 15 years as an investment account. So, the higher the dollar amount is and the longer you keep the money in the bank, that 40 cents that you just saw as a growth from simple interest to compound interest in just 6 months, just imagine how much that will keep growing as you leave this money longer into this compound interest bank account. But this kind of just illustrates that there is at least a little bit of difference in doing just your basic simple interest calculation. So this would just be, simple interest formula, whereas this one over here is based on your compound interest. So you are going to get a little bit more money. So they're saying, notice how the future value is slightly larger than the principal. And this is happening because, it includes both the principal and a little of that interest you had from the first quarter. So your compound interest formula, as you can see, when we did our little 8% multiplied by just a quarter, 1/4 of the time, it gave us 2% as our interest rate for, a quarterly time period. So what happens here is they're talking about the compounding period is the time period over which any one interest payment is calculated. So, compounding period in our example that we just looked at was at quarter of a year. Now they're talking about the periodic rate. I is the interest rate which is charged for each period. So of course, in our example, our periodic rate was going to be 2% because we took that 8% and divided it by 4. And so they're actually kind of getting into the whole calculation here of how they are coming up with the compound interest formula in comparison to the simple interest formula. So they're starting out about talking, we started with the principal amount and we added 1 plus I. And remember, I is again this periodic rate of 2%, specific to our example. Now, when you got into the first quarter, into the second quarter, you basically, what you did was you kept, so they're talking about this is the account balance that was at the beginning of the second period. So this is what we would have, this future value over here would be at the beginning. Now, so this will end up becoming your new principal when you get into the next, time period, the next quarter. So they're saying the account balance at the end of the second period will then end up becoming, this principal, the original principal with 1 plus I to the second power. And then we would be calculating an interest again at the end of that second period. So that's actually what your balance would end up becoming at the end of your third period. So then that is going to be, the P1 plus I quantity squared was at the beginning of the third period, but by the time you get to the end, well, you would actually end up with this one over here. But basically what happens is if you look at just the final compound interest formula over here, this exponential value is actually going to coincide with how many periods are you breaking any given year into. So are you going to break it up into quarters? If you're breaking up into quarters, you will actually have the fourth power on your exponent over here, because we're basically saying you're calculating interest 4 times a year. Now these compounding period that we're talking about here is the time period when your interest is being calculated. That can actually keep changing because your compounding period, and I don't know if I mentioned that in here, your compounding period can be in terms of monthly. So that means your interest can be calculated 12 times a month. Your compounding period, of course, you saw can be quarterly. It can be semi-annually, which means it's calculated twice a year, at the end of 6 months. It can honestly also be broken down into weekly, daily, hourly. I mean, that compounding period, depending on what account you are looking at and what kind of institution you're working with, those compounding periods really do keep changing over time. So again, just some terminology here. The R will be representing your annual rate of interest. I basically represents the periodic rate. So that's where you take your R. And, honestly, I prefer to write this guy here as, I wish this pen would stop acting so weird. Okay, so your I is basically where you take your annual rate of interest and you divide it by your compounding period. So how many compounding periods you are going to have. So that's actually how you calculate your periodic rate of interest. And, of course, the I is going to be the actual dollar amount. So coming back to that same example with our Tom and Betty's 8%, depositing $1,000 in that bank account. They're saying find your I and N value. So this was 8% interest rate compounded quarterly. So that means you are taking your 8%, dividing it by 4, which will end up giving you 2% or 0.02. And then when we put that into this compound interest formula, you will have P, which is 1,000, 1 plus I is this new interest rate we calculated, so 2%. And we were only doing this, remember, for 6 months. 6 months is how many quarters? Well, 2 quarters. So that's going to be your exponent of 2, and you will see you, of course, end up getting the same dollar amount. your textbook is actually kind of changing this formula. For most other textbooks, if you look at the compound interest formula, they actually give it to you as future value equals P 1 plus R over N, and then N multiplied by T. And so most of the textbooks, you will actually see that this is the formula that they use. Now your, like I said, your textbook is kind of changing it up a bit, but if this is a formula you're familiar with, you can do it that way. If you want to do it the way your textbook is talking about, of course, you can use either of them. They're still going to get you to the same result. So let's take a look at another example here. We're talking about in 1777, it looked as though the Revolutionary War was about to be lost. George Washington troops were camped at Valley Forge. They had minimal supplies. The winter was brutal. So they're saying, according to a 1990 class actions lawsuit, basically, Jacob DeHaven, a wealthy Pennsylvania merchant, saved Washington's troops and the revolutionary cause by loaning Washington $450,000. So basically this person, Jacob DeHaven, loaned money to Washington so, the Revolutionary War could continue. So this suit that was filed in 1990 were filed by the descendants of DeHaven, and they were asking the government to repay the still outstanding loan plus any compound interest they would have earned, at back in the day, the prevailing rate of 6%. So basically they were saying, okay, you owe us money for, when we loaned money back in 1777. So they're asking us to find the I and the N. So the I is your periodic rate. So they're telling us the annual interest rate is 6%. And they are talking about compounding it monthly. So since they're talking about compounding it monthly, we're dividing it by 12 because again, there's 12 months to a year. So 6%, 0.06 divided by 12 will give you a periodic, which means a monthly rate of 0.005. Now let's talk about, well, how many compounding periods do we have? So that means you're looking at, going from 1990 when the lawsuit was filed to when the loan was made to George Washington in 1777. So that's a total of 213 years, since that has happened. And since we're talking about compounding this monthly, you take your 213 years and you multiply the 213 into 12 months. So 213 multiplied by 12 will give us a total of 2,556 months. So at 0.005 interest rate for 2,556 months, well, how much money do you think, the government would owe this DeHaven family? So they're plugging this into your future value formula for compound interest. So the loan was made in the amount of $450,000. You are taking your periodic interest rate, which was 0.06 divided by 12. They could have also used 0.005 instead of this fraction here. And then your exponent is going to be, the total number of compounding periods. So that's 2,556. So when they put this into the calculator, this is kind of what they're coming up with. And if you see, this is coming out to be what? 100,000 million billion. So that's what? 154 billion, 762 million, $723,400 is what they sued the US government for, because they said, okay, this is the amount of money you owe us. And it's kind of interesting because they do get into a little bit more detail about this lawsuit, and they were saying, that we're suing you for this amount, but they said they were willing to accept a more reasonable payment in this case. So they're saying, notice how the future value is so much higher than the principal itself. And, of course, this is going to be because, this is compound interest. Compound interest grows at an exponential rate. So even though they may have only loaned, close to $500,000 back in 1777, over those 213 period, but, at a monthly compounding, you can see you're talking about 2,500 months or more than that, this interest would be accumulating. So they're basically saying, and if you look at this paragraph here, that there's no evidence to support the claim of the DeHaven family, lent that money to George Washington. And they're saying just, a little detail about the tradition first appeared in print in a DeHaven family history, and they're talking about the descendants make attempts to get the loan repaid, but there's obviously evidence to show you that that may not have been true. So obviously that lawsuit did not go anywhere, and they did not get paid for that. But you can kind of read some of this description over here. But it's just kind of neat to see how high your payments can go based on the interest rate, the dollar amount, and the time period, how long that investment has been happening for. So let us take probably a more reasonable example than this lawsuit over here, and see if we can just use this formula to help us out a little. So we'll just start with something basic over here, just with different compounding periods to show you how these work. Okay, so how about okay, so with section 5.2, let's take a look at these examples over here. Oops. Okay, so we'll look for this at different compounding periods. So let's take a look at, how about number 14 and 16. So you can see with number 14, we've got, our loan amount, our interest, compounding period, and for how long. And then for number 16, again, you've got your loan amount, the rate of interest, your compounding period, and this is for 10 years and 182 days. So let's see what happens in that case. So let's start out with number 14 over here. Okay, so they're telling us that the amount, as it can be invested or borrowed, is at 36,820. Our rate of interest is 7 7/8%. They're telling us it's being compounded quarterly. And our time is for 4 years. Okay, so the formula, the way it's given to us in your textbook, is principal 1 plus I to the nth power, or like I said, I actually prefer the other way around. Because honestly, the way this formula works, your I, as I showed you, is defined as R over N. And this N value, and just to show that maybe it's a little bit of a different variable, let's use capital N for this guy. So that capital N is actually N, small n multiplied by T. And you know, this guy is what I would call as my small n value. Whoa, didn't mean to do that. Because when they're saying quarterly, that means you are looking at a compounding period of, you know, 4 quarters in a year. So if you think about this, if we were to do this calculation here for the I, you would take your rate of interest, which is of 7/7/8. You know, of course, we would need to convert that into decimals. So your 7/7/8 would actually end up becoming, you know, 7 point, if you just convert those 7/8 into decimal, 7/8 is 8.875. So, you know, you would be taking your rate of interest, which is 7.875, and this is still in percent. You know, we would need to convert that to a decimal. And you would be dividing this by, you know, there are 4 quarters in a year, and this would give you the, you know, periodic rate. Now for this capital N, which is the formula from your textbook, to calculate this capital N, you would be taking your 4 quarters in a year, multiplying it by total number of years, which is also 4 years. So that would end up giving us, you know, 16 as our compounding periods, I think is what your book is calling it. So you would have 16 compounding periods, and you can see that n times t is the same exponent you have over here, which is what we would need to calculate. This I, where you have 1 plus I, is r divided by n, and so that I is the same thing as r divided by n. So your formulas are not different, it's just the way they present it to you. So if you were to go ahead and calculate your rate of interest as a decimal, you know, we would move that 2 decimal places to the left. So you would end up with 0.07875. So in this calculation over here, you know, for the I, we would end up doing 0.07875 divided by 4. And what will that come out to be? 0.0196875. And again, you cannot round any of those decimals. So, you know, that's the reason why I'm not a big fan of the way your textbook does it. But, you know, I know that's your reference. And if that's what you are comfortable with, you can definitely go ahead and use this formula from your textbook. But the way I would write this out is I would say, okay, I want to calculate my future value. My principal amount here is 36,820. And then we are going to be adding 1 plus for this I. I would probably just leave it as a fraction of 0.07875 divided by 4. And then for your exponent, you can either use the 16 compounding periods like we calculated the capital N over here, or if you just want to do 4 quarters multiplied by 4 years, you know, you can definitely do 4 times 4 over here, or like I said, you can do 16 over here. But for that I value, I would leave it as a fraction. So when you type this into your calculator, you don't have to worry about, you know, all those decimals that you get from that 0.0196875. Now, another thing I will tell you, you can actually type this whole entire thing in your calculator just at, you know, all at once. So the way you can do this is you can type in, let's see, and of course we would start out with that 36,820. Then you would use your multiplication parentheses, 1 plus 0.07875, divide that by 4, close your parentheses, because, you know, we want the calculator to know that all of this calculation is happening inside the parentheses. And then depending on your calculator, you may have this little caret symbol for the exponent. Some of you may have this y to the x key, so you would just have to play around and see how you enter exponents in your calculator. And then you would type the 16, which is our exponent, and then you would hit equal to or enter, you know, whatever your key is. So you will be able to type all of this in if you don't want to, you know, mess around with typing all those decimals. So go ahead, do your calculation, and let's see what dollar amount we are seeing over this, you know, 16 quarters. By how much is this money going to increase? Now, if your calculator is not allowing you to do all of this at once, you know, at the same time, then you may actually have to break it up into pieces. And if you have to break it up into pieces, then, you know, you probably want to start on the inside of the parentheses first. So in that case, I would say start with the 0.07875 divided by 4, hit enter. Whatever answer you get over here, then you will add 1 to that, you know, again, hit enter. The new answer you get, then you would actually have to do the exponent first, because, you know, you're just following order of operations. So then you would raise it to 16, hit enter, and then whatever answer you got after that, then the final thing would be to multiply it into that 36,820, and, you know, then get your very final answer. So let's see, Isabel, you came up with $50,298, and it looks like if you have 764, then technically 76 cents, I guess. Alrighty, so let's see, 50298, and the decimals that I actually came up with was 76382. So rounding it to 2 decimal places after the 6, since you have a 3, you know, the 3 is not going to change your number, but this guy will just round up to $50,298.76. Okay. So this was using quarterly as your compounding period. Now with number 16, I think they were doing it daily. So let's look at number 16 over here. Okay, so our principal amount that we are looking at is 12,350. Our rate of interest is 6%, so that would be 0.06 in decimals. You've got compounded daily. And, you know, usually for daily, we use 365 days as our numerical value. And then they're telling us the time for this is going to be 10 years and 182 days. So, you know, of course, we would need to convert everything into years before we can put this into our formula. So let's see how we can break this guy down. Okay, so let's see. Again, your formula. Again, remember your I is R divided by N. Capital N is N times T, and we're thinking of this 365 being your N value here. So you would be taking your principal of 12,350, multiplying it with 1 plus I is R divided by N, so that is our 6%, so 0.06. Divided by our N value, which is of course going to be 365, because that's what our compounding period is. It's daily. And then for your exponent, the NT, that's the calculation we will kind of need to figure out what this number is going to be. So let's take a look at how do we want to do this? Because we have to do N times T, and our T is 10 years and 182 days. Okay, so let's take a look at this guy. So our N value is 365. Our T is 10 years plus 182 days. Now this pen is really driving me crazy today. Now, typically when you are talking about your time, remember how we said all time has to be converted into years? So technically, what we would have to do is we would have to take this 182 days and we would have to divide it by 365 days so we could convert this into years. And, we talked about doing that right here in this example where we were looking at the credit card charges. You had 30 days, in that given month. The billing period, and so we divided it by 365. So that's actually the same idea over here with the 10 years and 182 days. We would need to divide it by 365. So technically, you should actually have your little division over here with the 365. So what happens when you do this N times T, or calculating that exponent over here? This 365 will have to be distributed between these two quantities and our T time for the year. So you would actually end up multiplying 365 with 10 years, and then on the other side you would actually be multiplying 365 with this fraction. Quit acting so finicky. Okay. You will be multiplying it with 182 over 365. And it's kind of interesting how this works out, because your 365 would cancel each other out, and you would honestly just end up taking the 365 times 10 over here in the first part and just adding 182. So all you are doing is converting those 10 years into days, which will come out to be 3,650 days. You would be adding 182 to that number, and that would honestly just tell you for how long you are going to calculate your interest for. So this is going to end up becoming 3,832 days, and that becomes your exponent over here, 3,832. So just as a quick recap with this, they're telling us our daily is the compounding period. And again, you can see that here under number 16, they're telling us it's 6% compounded daily. So that's 365 days in a year. They're telling us the time period for this investment is 10 years and 182 days. Now 182, since that's given to us in days, to convert those into years, we divide it by 365. So, basically for this guy, you are looking at time as 10 plus 182 over 365, and this is going to be in years when you divide that 182 by 365. So to calculate what your exponent will be, you are taking these 10 plus 182 over 365, and you still have to multiply into that daily compounded value of 365. So essentially what happens is you just end up multiplying 365 into 10. With the 182 over 365, those 365s end up canceling each other out, and you just end up with 365 multiplied into 10, which gives us 3,650, and then you just add those remaining days of 182, and it tells you how many total days are we going to be calculating this compound interest for, and it comes out to be 3,832, and that becomes your exponent. So this is going to be, our calculation that we need to now figure out. So we will be looking at our future value of principal of 12,350 being multiplied with 1 plus our 6% divided by 365, and then our exponent is 3,832. So when we go through this calculation, what does our future value end up looking like in this case? Okay, let's see, you've got 23,185 and 38 cents. Okay, so you've got 12,350, and then we've got 1 plus 0.06 divided by 365 raised to 3832. Alrighty, very nice. So as your raw answer, you've got 23,185.38447. So again, when you round it to the nearest cent, since you have 0.384, that 4 really doesn't change your answer. So very nice, Isabel. 23,185.38. So just be careful, look through the answers, what kind of compounding period you've got, and how those calculations will be affected. If you look at some of the other problems over here at the beginning, they were actually giving you compounded annually. So compounded annually means you're only calculating your interest once a year. So in this case, your compounding period, would just be number 1. With quarterly, it's 4. Daily, it's 365. Okay, so this next part over here in your handout is actually just talking about comparing simple interest with compound interest. So they're talking about, if you look at example 4 over here, they're saying how much would the government have owed the D havens if the simple interest, if the interest rate was simple interest. So instead of doing, compounded monthly like they're talking about here, what if we just did simple interest? So in this case, you would be looking at a principal of $450,000. We're still doing 6% interest rate, but now you would actually only be doing this for 213 years, instead of that 2,556 months, because you're not compounding this anymore. So you will see when we put this through our simple interest formula, you actually just come up with $6,201,000. Now look at that, that's 6 million and some change, as opposed to 154 billion and 700 something million after that. So just look at keeping the same dollar amount, same rate of interest, same time frame, but you changed it from compound interest to simple interest, and look how much less that dollar amount is going to be. So compound interest really does make a difference, and that's the reason why we prefer compound interest on investments, right, where your money is growing, as opposed to a loan, because with a loan you can imagine how much more you end up paying in that case. So they're just talking about just doing some comparison over here with this little table. So you can see we're actually talking about depositing $1,000 at 10% interest rate. And you can see different time frames after 1 year, after 10 years, and after 30 years. How does that amount grow? So at simple interest, if we calculated $1,000 at 10%, at the end of the first year, we would have $1,100, $2,000 by 10 years, and $4,000 by the end of 30 years. So, you know, I mean, yeah, the money has grown, but obviously not a whole lot. Now, if we did compounded, but this is annually, which means you're counting your interest just once a year. So for the first year, there will be no difference because, you know, simple interest and compounded annually actually have pretty much the same calculation for the first year. But now look at with the compound interest, how much does this amount grow from, you know, simple interest to compound interest? You went from $2,000 to $2,593.74. But 30 years, that's a big difference because you went from 4,000 to 17,000, almost $500, you know, by the end of 30 years. Now, if we change this compounding period from annually to quarterly, look at that. Even with quarterly, you are earning a little bit extra money from just, you know, 1,100 to 1,103 and 81 cents. If you go from quarterly to monthly, you're getting, again, just a little bit more money, $4.71 on top of that 1,100. And compounded daily is actually going to give you $1,105.16. Now look at these dollar amounts, you know, after 10 years. So we had 2,593 over here. This is now 2,685, 2,707, 2,717. So again, money keeps growing. 30 years is going to be the most significant. We went from 17,500 almost to 19,358, 19,837, and look at that compounded daily at 30 years, $20,077.29. So the compounding period makes a difference, and also the number of years makes a big difference on how your money grows. So compound interest, guys, is definitely a great calculation. Like I said, especially when it comes to investments. So we actually just have a little tiny part of 5.2 to finish. So for next class, we will finish 5.2 and we'll actually start in chapter 8. Chapter 8, again, we're only doing 2 sections, so we're not really doing big chunks. At this point, we're just doing, you know, the necessary sections that is required for this class. So Tuesday morning, we will do 5.2 and get into chapter 8. But then remember, next Thursday is Thanksgiving, so we don't have class next week, only on Monday, Tuesday, and then no class for the rest of the week. So we'll be coming back the week after Thanksgiving after that. So just one more class, and then we go on Thanksgiving break, and that's my goal, is to finish chapter 5 and see how much of chapter 8 we can do. So please keep in mind, those of you who have not finished your exam, you have till midnight today to finish your chapter 4 homework, quiz, and exam. Please do not wait any longer than that, okay? So have a wonderful day, guys. Have a wonderful weekend, and I will see you on Tuesday morning. Be careful. Stay safe, everyone. Take care.